All right, so we're going to step it up a notch, and this time we're actually going to find the point of inflection. So remember, if you ever need a y coordinate, where do you go? Back to your original function. So my first derivative, and again, I know I'm repeating myself, is a negative 28x to the third. That tells you increasing, decreasing, maxes, and mins. And my second derivative is going to be 3. I don't know what that is. 28 times 3 is negative 84 x squared. Okay, so I need to take that and set it equal to 0. Now be very, very, very careful. Do not divide both sides by negative 84. If you divide by a negative, you flip this, which means your concavity will be inverted. So for ease, I am going to divide both sides by positive 84, okay? And this is going to be where I put my test points. So now you can divide both sides by negative 1, take a square root, so x equals 0. All right, so if x is 0, this is where I put my test points. So to the left is negative 1. Negative 1 squared is 1. Change its sign, so it is concave down. And then give me a point to the right of 0. It could be 10, so that gives me negative 100. So again, he is concave down, so he does not change concavity. He is concave down for all real numbers from negative infinity to positive infinity, and your point of inflection does not exist because it does not change from concave down to concave up or from concave up to concave down. Okay, so your point of inflection is a DNE. All right, so another one will be, let's try this one. I'm flipping everything. All right, so x to the third. I have f of x equals x to the third minus 6x squared. And then plus 22x and minus 28. So my mission is to find a concavity and then find its points of inflection. So first derivative will tell me increasing, decreasing, maxes, and mins. Okay. Second derivative will tell me concavity and points of inflection. So I end up with a 6x minus 12. Okay, take that, set it equal to 0. This is also going to be, you could divide both sides by 6 if you want to, but that's really not hard math, so we're just not going to. All right, so this is where I'll put my test numbers. So add 12, divide by 6, I get x equals 2. So if I test this, this is where I'm going to put my test values. So try 0, that's to the left of 2. So 6 times 0 minus 12 is negative. And then after 2 is 10. So 6 times 10 minus 12 is positive. So he is concave up from 2 to positive infinity. He is concave down from negative infinity to 2. And because 2 exists in your domain, okay, it's not an asymptote or anything like that, excuse me. I've got a point of inflection at 2. So my point of inflection is going to be 2 comma something. Well, anytime you need to know a y coordinate, go back to your original function. So 2 to the third is 8 minus 6 times 2 squared is 24 plus 44, sorry, minus 28. Okay, so I'm not even trying to do this in my head. So 8 minus 24 plus 44 minus 28 gives me 0. So your point of inflection occurs at an xy coordinate of 2, 0. All right, so for the next one, we have f of x equals x times the square root of the quantity of x plus 12. And I'm going to rewrite that as x plus 12 raised to the 1/2. Okay, so remember, you don't want anything underneath your radical to go negative. So say I need you to be positive, okay, which is everything bigger than 0, but you can also be 0 because the square root of 0 is 0. So I'm going to add 12. I'm sorry, subtract 12. Okay, so right now I know that this thing only exists from negative 12 and bigger. So if I generate anything to the left of negative 12, it is not valid because it's not in the original function's domain. All right, so first derivative gives me increasing, decreasing maxes and mins. So first, I'm going to do product rule. First times the derivative of the second, which is x plus 12 to the negative 1/2, plus the second times the derivative of the first, which is 1. Okay, so I'm going to clean this up a little bit. I have f prime of x equals x over 2 times x plus 12 to the positive 1/2 plus x plus 12 to the positive 1/2. So on this one, I'm going to do quotient rule. On this one, I'm just going to do it. All right, so I have f double prime of x is going to be the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is, drop your 1/2 out front so it cancels the 2, and then x plus 12 to the negative 1/2. All over the bottom squared. Remember, you're squaring this entire thing. So 2 squared is 4, and the square root squared is just going to be x plus 12. Okay? And then this one becomes, drop your exponent out front, okay, times what's sitting there, drop your exponent by 1. Excuse me. All right, so we've got a mess here. So we're just going to clean this thing up as best we can. And I'm going to go ahead, how do I want to do this? What's the easiest way? I'm going to pause and think. I'm going to get a common denominator. So this denominator is a 4x plus 12. So if I multiply top and bottom of this one times 4x plus 12, okay, that's what you're doing, is top and bottom is 4x plus 12. That way I can write this thing as one big fat fraction and just deal with the numerator. All right, so that's going to give me a 2 times the square root of x plus 12 minus x over the square root of x plus 12 plus, and now I have this thing multiplied, because remember this entire thing is going to be over 4 times x plus 12. So this thing cleaned up. What is half of 4? It's 2. And then x plus 12 to the negative 1/2 times x plus 12 is going to be x plus 12 to the positive 1/2. So that gives me 2x plus 12 to the positive 1/2. Which means now I got 2 of these things, okay? Which means I have 4 of them. So that's what this thing reduced to. So this is now 4 of these things. I'm sorry, y'all. And then this is what I've got. Now, don't reduce the 4s or the x plus 12s or anything like that. Remember that negative 12 is off limits, and I should have told you that before. Way back up here in your first derivative, when this radical dropped to the bottom, negative 12 would result in a 0 in your denominator. So now negative 12 is off limits, okay? I'm still allowed to use everything over here, but now I cannot use negative 12. So if it's allowed in my original function but not allowed in my derivative, that means you've got a cusp there. Okay, so what have I got? I don't know. All right, I'm going to flip and multiply this thing. All right, so this, remember, I have this, and this is over 1. All right, so what this effectively is times 1 over 4x plus 12, and I'm going to distribute that to both of them. So this one, the 4's will reduce, and it'll be a 1 over the square root of x plus 12. Because x to the 1/2 over x plus 12 to the 1/2 over x plus 12 to the first. Subtract your exponents, you'll get a negative 1/2, which drops it to the bottom. Multiply over here, and I'll get a minus x over, and then you'll still have your 4, but this time your square root of x plus 12 will be in your numerator. That, my friends, is what needs to be equal to 0. Okay? So when I get this thing equal to 0, I'm going to go ahead and add this one to the other side, and I'm just going to cross multiply. So when I add this term over, it'll turn positive. And now cross multiply, I'll get a 4. And cross multiply this way, I'll get an x times x plus 12. Okay, so I get a 4 equals x squared plus 12x. And then I'm going to subtract 4. Okay, and then I'm going to well, I don't care. All right, so do I have numbers that will make this thing work? Hang on. 2 numbers, I don't want to go through and complete the square. So we have x squared plus 12x minus 4. And I'm just going to graph it just to see if I've got any real numbers. Oh, I do. Well, lovely. All right, so hang on a second. Dadgummit, I'm going to have to go into a 4th video. Anyway. All right, so what I have here is, if I complete the square, so I'm going to add my 4 back over. Okay. Look, there he went. So there's my 4. Half of 12 is 6, squared is 36, so I just added 36 to both sides. So I get 40 equals x plus 6 squared. Take a square root, take a square root. So plus or minus, I would like to know what the square root of 40 is. And it is 6.32 something or another. Okay, so when I do that, I get plus or minus 40 square root equals x plus 6. So then I'm going to subtract 6 from both sides. So I get a negative 6 plus or minus the square root of 40 equals x. So if I have a negative 6 minus the square root of 40, that gives me a negative 12.32 something or another, which is out of my domain. So a negative 6 plus the square root of 40 will be roughly 0.32455. So 0.32455. So that is your test point. And I'm just going to use that decimal. When I resolve this, I'm going to use the exact value, but for right now, just for test points, I'm going to use this. All right, so for the log, where am I at? This is, hang on, my first, or my second derivative, okay? And honestly, this sounds so tacky, but we're in a rush, okay? I would shove that entire thing in your calculator and evaluate it at 0, and then evaluate it at 10, okay? And that's going to tell you where your concavity is. Now, where do I go if I need to know my original y coordinate? Because this is a point of inflection. This is where it's going to change change concavity, sorry. So take this value and input it back up into your original function to find your y coordinate. Okay, and I know that one was sloppy. I'm really sorry. All right, let's do one more, and then we're going to wrap it up. And I'm sorry, but there's going to be a 4th video. All right, so the last one, I got sine of x over 2, which I could rewrite as the sine of 1/2 x. And I'm only doing that so you'll remember that we've got to do chain rule. So my original function is, my first derivative is, the derivative of sine is cosine times the derivative of the inside. That tells you increasing, decreasing, maxes, and mins. So now the derivative of cosine is negative sine. So I have negative sine of 1/2 x times the derivative of the inside will give me a 4th. Okay, so this one is slightly easier. Your domain is all real numbers because sine is valid for all real numbers. I'm going to multiply both sides by 4. So I have a negative sine 1/2 x. So basically, where does sine equal 0? Sine equals 0 when x is 0, pi, and we're restricted from 0 to 4 pi. Okay, 0, pi, 2 pi, 3 pi, 4 pi, and it goes on and on and on and on. And I'm going to have to finish this on the next video, sorry.